All right, problem number 2, solve the system represented by the matrix below. You may convert to equations if you want. I'm not going to do that. I am going to solve this using matrix operations. So the very first thing I'm going to do is I am going to take the bottom row, row 3, and I'm going to divide it by 5, because doing so will give me 0, 0, 1, and then 25 divided by 5 is 5. That's our goal. Get a 1 down there, so I've got it. That's good. I can just rewrite everything else. 0, 4, 3, negative 1, 2, 3, negative 1, negative 11. Now what I'm going to do is I'm going to use that bottom row to make this 3 become a 0, which means which means I need to subtract 3 of row 3 from row 2. So let's say row 2 minus 3 row 3 is the operation I'm going to do now. Top is going to stay the same, 2, 3, negative 1, negative 11. Bottom's going to become 0, 4, 0 right there. I need to figure out what I get when I do this operation. So I'm taking row 2 and subtracting 3 of row 3. So for that last column there, I need to take that negative 1 right there, and I need to subtract 3 times that 5. So I'm subtracting 15, so negative 1 minus 15 is negative 16. So I get a negative 16 right there, and I get a 0, 0, and a 1, and I still have that 5 right there. Notice, next step, divide row 2 by 4 to turn that 4 into a 1, because now I'll have 2, 3, negative 1, negative 11, 0, 1, 0, negative 4, because I've divided by 4, and then 0, 0, 1, 5. So now I have my middle and bottom rows squared away, and I can use those to fix the top row. So what I'm going to do is I'm going to take row 2, I'm going to take row 1, and I'm going to subtract 3 of row 2. That is going to turn that into a 0, which is my goal. And then I am going to add to that 1 row 3, because then that will cancel out that term right there. So let's go ahead and do that real quick. So I will have a 2 there still. My 3 is going to be a 0. My negative 1 is going to be a 0. So now I need to do all those operations on that final term. So take the value of row 1, which is negative 11, subtract 3 row 2's from that. So I'm taking negative 11, and I am subtracting 3 times the row 2 value, which is negative 4. And then I need to add to that my row 3 value, which is 5. So let's do a little math real quick. Negative 11 minus 3 times negative 4. Well, minus 3 times negative 4 is a positive 12. Negative 11 plus 12 is a positive 1. 1 plus 5 is 6. So I get 2, 0, 0, 6 right there. Still have 0, 1, 0, negative 4. Still have 0, 0, 1, 5 right there. So my last step, all I need to do is take row 1 and divide it by 2. And I'll get 1, 0, 0. 6 divided by 2 is 3. And I get 0, 1, 0, negative 4. And 0, 0, 1 is 5. So if I was letting this be an x row, a y row, and a z row, 0, I would be saying x equals 3, y equals negative 4, and z equals 5. Now you can do that as equations as well. It's arguable which one you prefer, but I would write a system 2x plus 3y minus z equals negative 11, and then I would say 4y plus 3z equals negative 1, and then finally I would say 5z equals 25. And it might honestly even be easier to do it this way, because I could right off the bat say z equals 5 by dividing by 5. Then I could use that middle equation, 4y plus 3z, which is 5, equals negative 1. So 4y plus 15 equals negative 1. So 4y equals negative 16, and so y equals negative 4. And then I could plug both y and z back into the first equation. So 2x, which I don't know, plus 3y, 3 times negative 4, minus z, which is 5, equals negative 11. And I can simplify all that there. 2x plus 3 times negative 4 is negative 12, minus 5 equals negative 11. Simplify, simplify, simplify. 2x minus 17 equals negative 11. So add 17 to both sides. 2x equals 17 minus 11 is 6, and so x equals 3. Totally fine doing it either way. I like row ops. I think they're fun. I'll often combine multiple row ops at a time to make the process more streamlined. You do whatever you prefer.